Welcome back to our channel. Today, we have a critical and thought-provoking topic to explore. Imagine this. A massive asteroid is hurtling towards Earth with a high impact probability. We have over a decade to prepare, but are we truly ready to face such a catastrophic event? In April 2024, NASA conducted a groundbreaking exercise that brought together nearly 100 representatives from various U.S. government agencies and international partners. This wasn't just any ordinary meeting. It was a planetary defense interagency tabletop exercise, simulating humanity's response to a hypothetical asteroid threat. The premise was nothing short of alarming. A previously undetected asteroid had been identified, and initial calculations indicated a 72% chance of it striking Earth on July 12, 2038. That's just 14.25 years away. The simulation revealed some unsettling truths about our preparedness, or rather, the lack of it. As we dive into the details of this exercise, we'll uncover the daunting challenges the participants face, the critical gaps in our global preparedness, and the steps being taken to fortify our defenses. From the uncertainties of initial observations to the urgent need for international collaboration, this exercise provided valuable insights into what could be humanity's greatest test. So, buckle up and join us on this journey as we explore NASA's latest efforts in planetary defense. This is more than just a simulation. It's a wake-up call for all of us. Are we ready to handle the unthinkable? Let's find out. The hypothetical threat began with a startling discovery. An asteroid, previously undetected, was found to be on a potential collision course with Earth. This celestial body, traveling at tens of thousands of miles per hour, could strike our planet on July 12, 2038. Initially, astronomers detected the asteroid using ground-based telescopes. Its sudden appearance highlighted a significant vulnerability in our current detection capabilities. Despite the advancements in space observation, many asteroids, especially those coming from the direction of the Sun, can remain hidden until it's almost too late. As soon as the asteroid was identified, experts began calculating its trajectory. The results were alarming: a 72% chance of impact, with a potential strike zone spanning multiple continents. This calculation set off a flurry of activity, as scientists and policymakers scrambled to gather more data and develop a response strategy. The size and composition of the asteroid were critical unknowns. Without this information, predicting the potential damage and planning an effective response was nearly impossible. Was it a solid rock, a loose pile of rubble, or a metallic body? Each type posed different threats and required different mitigation strategies. To make matters worse, follow-up observations had to be delayed for at least 7 months. Why? Because the asteroid was moving behind the Sun, rendering it invisible to our telescopes. This loss of precious time meant that the initial uncertainty would persist, complicating efforts to prepare and respond. The uncertainties in these initial conditions allowed participants to consider a particularly challenging set of circumstances, explained Lindley Johnson, Planetary Defense Officer Emeritus at NASA headquarters. This exercise revealed just how complex and uncertain an asteroid threat can be. With preliminary observations providing insufficient data, participants had to grapple with the reality that early detection is only the first step in a long and uncertain process of planetary defense. The stakes couldn't be higher. The hypothetical impact could result in catastrophic damage, ranging from regional destruction to a global catastrophe. Understanding the asteroid's threat and developing an effective response strategy was crucial, and this exercise underscored the urgency of improving our detection and preparedness capabilities. As we continue, we'll delve into the specific challenges and uncertainties faced during the simulation and what they reveal about our current state of readiness. Stay tuned as we explore the intricate details of NASA's asteroid impact simulation. As the simulation unfolded, participants quickly confronted a series of daunting challenges and uncertainties that highlighted the fragility of our preparedness. One of the primary challenges stemmed from the initial observations of the asteroid. Despite detecting its existence, scientists lacked crucial information about its size, composition, and trajectory. These uncertainties were exacerbated by the asteroid's trajectory, which took it behind the Sun, rendering it invisible to telescopes for several months. This critical delay in follow-up observations meant that critical details needed for effective response planning remained elusive. The uncertainties in these initial conditions allowed participants to consider a particularly challenging set of circumstances, explained Lindley Johnson, Planetary Defense Officer Emeritus at NASA headquarters. The exercise revealed the stark reality that even with advanced technology, predicting and preparing for a potential asteroid impact remains fraught with uncertainties. Decision-making processes were also thrust into the spotlight. Participants grappled with questions of risk tolerance and the readiness of global agencies to coordinate effectively in the face of an imminent threat. The need for swift and decisive action underscored the critical importance of international collaboration and unified protocols in disaster response. Moreover, the exercise highlighted gaps in our current capabilities. While significant strides have been made in detecting near-Earth objects, NEOs, and developing mitigation strategies, the simulation exposed the need for further advancements in technology and preparedness. The complexity of predicting an asteroid's behavior and the varying scenarios of potential impact underscored the necessity for continuous innovation and improvement in planetary defense. As we delve deeper into the implications of this simulation, it becomes clear that the hypothetical scenario is not just a theoretical exercise, but a call to action. Are we ready to confront the uncertainties and challenges of a potential asteroid impact? Stay tuned as we explore the next steps in fortifying our defenses and ensuring Earth's safety in the cosmos. As the simulation unfolded, one of the most glaring revelations was the significant gaps in global preparedness. Despite advances in technology and collaborative efforts, the exercise exposed critical deficiencies that could hinder our ability to effectively respond to an asteroid threat. Decision-making processes emerged as a central concern. Participants grappled with questions of risk assessment, tolerance for uncertainty, and the readiness of governmental and international agencies to swiftly coordinate in a crisis. The need for clear protocols and rapid information sharing became glaringly evident as teams simulated responses to escalating threats. Timely international coordination was another key area of concern. The exercise highlighted the complexities of aligning diverse national interests, policies, and resources in the face of an imminent global threat. Effective communication channels and mutual understanding among stakeholders were identified as essential prerequisites for a unified and efficient response. Furthermore, the simulation underscored the critical importance of advancing our detection and characterization capabilities. While NASA's NEO Surveyor promises significant improvements in identifying near-Earth objects, the exercise revealed the ongoing challenges in predicting asteroid behavior and assessing potential impact scenarios accurately. This exercise provided valuable insights into the risks, response options, and opportunities for collaboration posed by varying scenarios, remarked Lindley Johnson, Planetary Defense Officer Emeritus at NASA headquarters. The findings emphasized the urgent need for continued investment in technology, research, and international cooperation to bolster our planetary defense capabilities. In conclusion, while progress has been made in understanding and mitigating asteroid threats, the simulation highlighted critical gaps that must be addressed. From enhancing decision-making frameworks to strengthening global communication networks and advancing detection technologies, the path forward demands a concerted effort from all stakeholders. Despite the sobering findings of the simulation, there have been significant strides in planetary defense efforts. A notable achievement highlighted during the exercise was NASA's DART mission, Double Asteroid Redirection Test. This groundbreaking mission demonstrated the feasibility of using a kinetic impactor to alter an asteroid's trajectory, potentially diverting it away from Earth's path. The success of the DART mission marked a pivotal moment in our ability to mitigate asteroid threats. By validating kinetic impact as a viable deflection strategy, NASA has laid the groundwork for future missions that could safeguard Earth from potentially hazardous asteroids. Looking ahead, NASA is actively developing the NEO Surveyor, an infrared space telescope designed to detect and characterize near-Earth objects, NEOs, long before they pose a threat. Scheduled for launch in 2028, NEO Surveyor promises to significantly enhance our ability to monitor and predict asteroid impacts, providing crucial data for early warning systems and mitigation strategies. As we conclude, it's clear that while progress has been made in asteroid detection and mitigation, significant challenges remain. The simulation highlighted critical gaps in global preparedness, from decision-making frameworks to international coordination, underscoring the need for unified efforts to enhance our planetary defense capabilities. The success of NASA's DART mission and the upcoming launch of the NEO Surveyor telescope are promising steps forward. However, it's essential to continue investing in technology, research, and international collaboration to strengthen our readiness for potential asteroid impacts. Together, we must remain vigilant and proactive in preparing for the unthinkable. By advancing our capabilities and working together as a global community, we can better protect Earth and ensure a safer future for generations to come. Thank you for joining us on this journey through NASA's asteroid impact simulation. If you found this video insightful, please like, share, and subscribe for more updates on space exploration and planetary defense. Let's stay informed and prepared as we navigate the vast and unpredictable cosmos. Until next time, keep looking to the stars with curiosity and determination. See you in the next video.